Alright, mastering SolidWorks Chapter 38, using plastic features. SolidWorks have several tools specially designed with a model to evaluate plastic parts. These tools can help simplify and standardize some of the complex repetitive tasks involved with plastic part design. You can manually do all the work with the tools will automate, which is useful with the automated tools that do not provide the necessary option flexibility. The more complex your model, the more comfortable you would need with the workaround techniques. Some of the specific need of the plastic part model SolidWorks also have those powerful evaluation tools, helping you examine your models and check them out with the draft thickness and location of the undercuts surrounding design related to manufacturing problem. The manufacturer is expensive to find these design effort offices. Is far less expensive than conserves time. Having the good grasp of evaluation tools important with the component with a good plastic parts and mold. The practice is a chapter written from those who have already experienced with the plastic practice with the terminology. If you do not understand SolidWorks tools, you have the plastic molding and change of the chapter. I assume that you've already have the grasp of the basic plastic molding design terminology. In this chapter, you will learn to explore plastic features using plastic evaluation tools. Using plastic features. Plastic features available in SolidWorks are mount base, mounting boss, snap hook, snap groove, cement lip, groove indented, as well as the more standard draft and shell. These features offer standardized, flexible geometry that help you make more consistent model with a more quickly less tiresome repetition. You find the most features discussed in this section. On the fastening feature of the toolbar with maintaining the features are on the features toolbar. Some of the features application beyond the just molded classic parts. Many molding, casting, net shape processes exist in plastic materials as well as metal and ceramics and composites. Mounting boss. The mounting boss feature enables you to place the boss with fins either in a hole or a pin on either end. This does not enable you with a counterbore hole. This doesn't enable you to place a counterboard hole or through a hole in the fastened screw boss. It is aimed primarily to press pins rather than screw bosses. 38.1 shows mounting boss property along with a preview of the boss and the progress of the part. Show the figure download materials available. The Willie website figure. File name chapter 38 right frame solid part. Shows mounting boss. You have the point, your direction, edge, boss type, enter boss type, selecting mounting face, ending deramming, mating edge, and then fins. Workflow of the mounting boss feature is follows. Select the spot of the part representing the boss, which will part with this can be with either flat or curved. The example 38.1 was because I selected the curved face, it is necessary to apply supply with the direction pull with the selected the flat face with the direction selection box. The next step won't be able to select the plane and planar edges the established axis of the boss. The usual with the direction drawn. Notice with the part drawn and shown the 38.1 axis established early when the part named the direction of the draw with the step of the option of the default. A with the direction normal to the face steps in step 1. Selecting existing circle edge to the line of the boss. The new boss with the concentric with the circle edge. The steps is optional. You can choose the dimension locate the boss after the feature is created. If you use the dimension, you cannot locate the boss while property manager is active. Boss panel with the mounting boss property manager is used to establish height and the other dimension. The central ball with the diameter draft the dimensions. The obvious that you can establish height with the dimension or by an open up to face of the selecting mating face option. There's no option with the offset with the face end condition. Fin panels on the mounting boss property manager give you the control of the alignment with the draft height with the width and pattern of the ribs around the boss. The fixed boss is of the direction vector such with the plane edge and the axis to establish rotational orientation of the ribs. You can use the sketch for this. Significant dimension value with the obvious the fin pattern function obvious except equal space option, which is available only when the number selected when the number selected is 2. You must select a vector establishing orientation of the fins which form at a right angle for the corner. Mounting hole pin enables you to specify a pin or a hole boss associated with the side of the interesting with a meat that doesn't enable to throw the holes and counterbolts from the outside of the part along with the associated screws and for clearance. SolidWorks has renamed favorites of the rest of the software styles. However, in the mounting boss and lip groove, it is called favorites. It saves settings like other favorites and style functionality. After you successfully accepted the creation of the boss, if you do not use the circular edge to locate the boss, step 3, you can expand the mounting boss feature in the feature manager, edit the 3D sketch under the boss, inside of the sketch at this point, which you can dimension locate precisely. Remember the dimension of the 3D sketch file, but use the special rule to get orthographic the dimensional parallel X, Y, and Z axis. You need to dimension from plane, 3-dimensional sketches. Dimensions do not snap to horizontal or vertical orientation. like 2D sketches. If you select a flat face for the initial position of the boss, you get a 2D sketch instead of a 3D sketch. Features created by the tool aren't manually editable. They are made by extruded rib feature for the accessible behind the mounted boss interface. You must go through the mounting boss property manager to edit feature, but you can edit sketches you can use to make. Feature can move the face, change side of it if you need to make something asymmetrically as a Solidworks feature. You can access the dimension double clicking the feature in the feature manager for the graphics window. To make a screw boss instead of a pin boss, you have the optional setting of the hardware boss in the mounting boss property as shown in CH38 Effective way of patterning single mounting boss features around a part is view the sketch, driven pattern feature of the feature, view the sketch and set points, which each point represent the center of the pattern instant. Refer to the model downloaded materials, examine the stretch driven sketch driven part option in the bottom of the feature manager, view the chapter 38 right frame solid part, file chain with the non-mirroring configuration isn't already there. Shift the mounting boss, you have the position of the hardware boss instead of the pin boss. Using snap hook and snap groove. Snap hook and snap hook groove are two separate features. Lip and groove combines both function in a single property manager to help you resolve the work together more easily. Figure 38.3 shows the property of the snap and hook feature along with a completed hook. Snap hook property manager will be with a completed hook feature. Show the snap hook. First select the reference hook's position and define with the vertical standing direction. Finally, the direction of the hook itself. The hook, the axis, the reverse direction, right hook, reverse direction, entire body height, select mating face, snap hook data, favorite and none. Workflow for the snap hook feature goes like this. Select the snap spot on the model that corresponds with the trim of the undercut edge of the where hook intersects the part. It looks like you can select the face edge where you first created the feature for the software. Allow the convert selection of the 3D sketch point when the feature is accepted. Select vector face edge axis for the non-sketch. Select the vertical orientation of the hook at the top. Another vector to define with the front of the hook undercut side. Two for the selecting mating face. Enter the number to define the height of the hook. This feature of the view of the 3D sketch point where you made the selection of step 1. You cannot dimension the point when selecting and setting up the feature of the you can dimension this point only by creating the feature going back, editing 3D sketch absorbed under the feature of this is arrangement with the lip and groove feature. Remember that you cannot dimension 3D sketches in the same way to dimension 2D sketches. You need to you may need dimensions to planes rather than edges to or points to get dimensions you really want. Snap groove property manager interface shown in Figure 38.4 along with the cross section finish snap hook and snap hook groove. To use the snap hook groove feature, you must already created the snap hook feature. The interface seems to imply that the body of the groove goes into must be the same part as the body of the hook feature, but this isn't the case. You can create the feature in context between a part with a hook and the part over the receive of the groove or in a multi-body part. Snap hook groove property manager completed hook and grooves. Select the snap hook feature in face-to-face creative groove. We have snap hook 1 extruded thin, and it shows the A, B, and C, and D, and the E of the hook of the snap groove. And before designers extend the undercuts and plastic parts, talk about the mold builder. If possible, the builder may have either limited or special capability that could impact the practicability of one with the approach opposed to another. Final beneficial work to close the model designer and builder on plastic part projects. When I molded plastic parts, rarely due to situation called for a generic snap feature, usually situation requires more inventiveness due to specifically restriction curvature of material thickness consideration. Snap hook groove features reasonably easy to use, but they may not have flexibility application in all situations. Using the lip groove feature, we went to the groove, lip and groove feature. We've choose our body part fillet interface. Groove selection phase, tangent propagation, edges, and tangent propagation shows previous jump gaps and using lip and groove feature enables you to create an matching lip of the groove with either the pair of the parts or assembling assembly or pair of bodies within a single part. With the Figure 38.5 shows lip groove property manager creating a groove within this part. Same interface also creates the lip feature. The workflow for this feature goes like this: select the part of the body to receive the groove, select the part of the body to receive the lip. If you want to create the groove, you can skip the lip steps. If you only want to create a groove, then you can skip the lip step. Select plane, planning your face straight edge, axis to establish the direction of pull. Select the face of the represented parting surface along with the area to the lip of the groove. Select the edge of the lip groove with will effect. Set the dimension of both lip and groove features. And most of the automated tools may not be able to create what you need. You can employ the others. Supplement manual workarounds, lips and grooves. On planning your parting line, you can use the sketch off the edge of the thing and extrude with either boss or cut. Using thin feature extrude, boss or cut can also be effective with planning your parting lines. Using trim, thicken, again, boss or cut. Surfaces can be effective but may also be more difficult. One of my favorite methods, especially in non-planing or parting lines, is to combine a thin feature with the extruded up to the offset surface by using a sweep, cut, adding material that can be effective with either planing or non-planar parting lines. Each of these really workaround techniques is not specific to the plastic molding tool. I won't go into the depth of these techniques here. I downloaded material for this. If you in the download material for this book, you'll find an example of the parts that demonstrate each technique. Alright, using the rib feature. Rib feature is a flexible tool creating a rib with a number of different situation. Ribbons can be drawn with two different orientations. Solidworks interface with a parallel to the sketch or normal to the sketch. Names are parallel with the dual tips of the open only with a cursor with a hovering over the icon. To become more precise, they want to really mean what is the rib will be created with either parallel, normal to the sketch plane. The sketch with a single line, it can be very difficult to tell the difference between a parallel and normal. To me, the names are very descriptive. I call the two orientation plan view from the top, looking at the direction of the drawing, normal to the sketch plane. Skyline, looking for the side, perpendicular to the direction of the draw. Rib is parallel to the sketch plane. To me, these names are more intuitive. The descriptive better reflect the function of the rib. Ribs can incorporate, draft, extend, trim, feature beyond the sketch automatically, breaking normal sketch rules, plan view, ribs only. Using 38.6 show the plan review violates normal sketch rules. Also shown the rib property manager. Some of the models of the download material show the example. Various rib techniques, rib feature and workflow should be self-explanatory. Draw the sketch either plan view of the skyline. Sketch representing the top of the rib. Material above it can be added between the sketch and the rest of the part. Remember that the sketch plan's directions make the difference. An issue with the feature set of the type of the rib, the direction. Use the flip material side toggle chain with the direction of the gray arrow, which should point at the top of the rib toward the part. Set the thickness, drop the mount with the direction. Alright, rib property manager, rib feature. And using draft and rib feature. When you create ribs, you also must apply with the draft to them. You must apply with the draft as a separate feature. If you can apply with the draft as part of the rib feature, can often easier with just as a part of the rib feature. But some people like to make all their drafts separate. The draft feature, but to keep the part face orthogonal and as long as possible, so that they organize all of the draft feature in order to fold their end of the feature manager, so that there's never any questions about which feature controls the draft. By default, when you apply with the draft as part of the rib feature, the draft is applied from the sketch end of the rib. This can cover the rib thickness of the problems you have created in the skyline rib, which the rib may have various heights. In this case, at the top of the rib, there will be various thickness that may cover the base of the rib to be thick. When you're working with this, sometimes you have to experiment with the proper thickness top of the rib in order to get the thickness at the bottom of the rib that doesn't cover the sink matrix on the outside face of the part. The solution to this is to use the at-wall interface option appear with it only after the enable draft and property manager Then you can specify the thickness of the draft so that the base of the rib maintains the specified thickness. Best practice when you're modeling plastic parts is best practice to model the part at maximum material and draft to remove the material. Alright, using intersection curve of the reference ribs are a feature that typically get inside hollowed out parts. For the reason they are often difficult to visualize, especially when they are on the plane that is deep down inside the part. We may find itself to use some sort of the reference show that the current sketch plane intersects the wall of the part. For this, I typically use the intersection curve of the technique that can be used in either planar view or skyline type ribs. Intersection curve tool of the sketch toolbar, which for the 2D sketch, activate with the tool with the select with the surface on the face. For the intersect with the current sketch plane, with the deactivate with the tool. When you finish, you may select all the lines selected with the intersected curve tool. Turn them into construction geometry. This provides good reference of the rib sketch without interfering with the rib feature. Figure 38.7 show the example. Use the intersection curve of the reference, setting up the rib sketch. The construction lines end with the below, with the right end of the skyline rib sketch are intersection curves. At the ends of the shell, the intersection curve serve to give the sketch of the reference point with a fully defined under the right end of the rib sketch. The intersection curve gives you the reference dimension height of the rib of the shallower section of the part with the part shown in Figure 38.7. Download material file number Chapter 38 Skyline Solid Part. Terminating rib feature automatically extends trims and base with the U of the rib sketch. This is greater extent easy with the function, but it tends to lead the sloppy sketching rib feature. If you sketch a rib and sketch does not lead all the way to the wall of the part, Solidworks extends it. If your sketch line goes past the wall, Solidworks trims the rib so that it only goes up to the wall over the part. In Figure 38.8 show how the two straight ribs are extended from the existing sketch on a pair of plane view ribs. Alright, sometimes you don't want a rib to extend with the wall part, but you want to terminate with the rib special location middle of the part. Try to do with this skyline rib at the end of the skyline section. Show the vertical plus the minus drive of the line over the points over the base of the part with the Figure 38.9. Show the accomplished for this. Note that on the left end of the rib, it extended with the straight down with the bottom of the part. On the right side of the rib, it extended up to the next wall. Terminating skyline rib. Final termination situation I mentioned one of the sometimes happening with the curved edge of the extension of the rib cannot be contained without the model rib will fail. Situation is not always obvious for that as you might think. Non-horizontal rib to intersect with the curved edge usually for you to take something a little Figure 38 showed an example of why this happens. The region of the air shown in Figure 38.10, even though the rib sketch intersect with the edge of the part, the width of the top of the rib would go past the edge of the not intersecting any. One way to deal with this is make a sketch intersect with the part with a lighter closer to the center of the part from the edge. Or the part 310 for the part wall does not terminate the rib. Alright, using thin feature extrusions are sometimes used to place a rib. The feature does not have all of the specialized options available to the rib feature, but they do offer simplicity and main abstraction. The thin feature substitute for the rib feature when the rib is standalone rib that does not touch both the sides of the wall of the part. They can be used in sketch extruded from the bottom of the rib, from the top, and extrude the thin feature from the draft. The end of the thickness faces go for the draft as well. Might cover the problem if you're trying to attach a rib to a wall. Extruding a thin feature down to the top of the rib can play for the plane view rib, but it won't enable you to break sketch rules like a plan view rib. Personally, I prefer the rib feature except for the freestanding ribs where you do not want to side extend up to the next wall. Alright, using drafting. Solidworks draft is surprisingly powerful in all simplicity. All expect the working with the draft could take up the entire chapter on its own. I try to hit all the most important points in this brief synopsis of the draft feature. Can rate three types of drafts. Neutral plane draft. The feature draft face of the plane and plane faces where the intersection draft face of the neutral plane is for the draft previous point pivoted bouts. Parting line draft of the feature of the draft face for the pivoted edge of the selected edges. Step draft feature draft face of the parting line edge of the can create a step at the parting line similar to pivoted drafting of the other software. 38.11 show the property manager draft feature including the draft expert, in which mentioned later in this section. Draft and draft expert and property managers. Neutral plane drafting workflow with a neutral plane drafting is follow the neutral plane with a plane and plane interface with the intersection draft the face does not move the direction move over the pole is always normal to the neutral plane. So for the draft angle with how many degrees of the direction pull with the vector selected face that should be tilted is not cumulative the angle so apply with 3 degrees of the draft to the face that is already drafted at 5 degrees. The result of 3 degrees rather than 8 degrees. Select the direction one side of the other side of the neutral plane. The arrow points directing decreasing material with the degrees of the drafting. A surface apply with the decreasing material concept that does not apply so that you don't have the experiment to see which direction is one you intend with the draft feature does not have the preview option. So the face of the draft, using the face propagation options, inner and outer face refer to inside of the outside loops around with the neutral plane faces. Also means all the faces have an edge of the neutral plane face. Parting line in the draft. Workflow, parting line draft is as follows. Selection and direction pull. This could be edge axis for the sketch plane of your faces. You also have the set of the direction pop with the negative along with selected directions. Select parting lines. These edge of the faces you want to draft. The parting line edge remains stationary while the rest of the face tilts along with the parting line of the selection. You may also need the other face option. Every edge is adjacent to the different face. The draft feature automatically selects the face and thinks that you want to draft, but it doesn't always get it right. The other face option enables you to intervene when the automatic selection is incorrect. Set the draft angle. Remember that you can use the allow reduction angle option if necessary. Alright, step draft. The most complex type of the draft is the Solidworks draft. The step draft. The step draft is either a non-linear parting line with parting line draft would cover the draft face to split into the multiple faces. The word step can be either refer to two different aspects of each. The first of the parting line can be said to be stepped parting line because of the non-linear two different levels. Second, the draft actually steps out of the draft face with the one level over the parting line. Step the draft to keep the face intact and true to do for the initial mismatch edge stop of the parting line. Figure 38:12 show the indifference for the parting line draft. Step the draft on the simplified part with the image of the left parting line draft the middle image of the step draft where a ledge is created only on one side of the parting line. The image of the right is essentially the double the step draft where the top side of the step is minimized by distributing across both sides of the step parting line drafting, and the image of this is slightly exaggerated to make it easier to see. So it's parting line draft, single step draft, double step draft. Workflow step draft is foul start of the part with a split line with an angled line makes an angle for more than 90 degrees rather than less than 90 degrees. Create a plane to define the direction of the pole located at the level of one of the split line single step draft with the midpoint of the angle of the double step draft with the location of the plane with the determine the pivot point with the drafted faces. Essentially, the line that intersects between the plane with the drafted faces will remain stationary, but the rest of the face will pivot around it. Initiate draft feature, set the option of the step draft, consult with your tooling people about whether to use the taper or perpendicular step. Perpendicular steps are probably the easiest tool. So the edge of the parting line, make sure the yellow arrows indicate the face to which you want to apply the draft. Step draft feature the can draft with only one side of the parting line at a time. Drafting face on the other side of the parting line does not require another step draft feature. You can use the neutral plane feature. Use the plane created step 2 with the neutral plane and maintain the step created with the step draft feature. Some draft limitations. One important limitation with the draft of the Solidworks is it cannot draft faces in both directions. Same feature. For example, if you have the parting line on one part and you must first draft the faces on one side of the parting line and then the faces on the other side of the parting line, when this resolves the two sides of the draft feature rather than one, it's simply inconvenience. Another inconvenience of the effect of the main feature of the addition with the draft that you can only draft faces with a single body at a time. Understandable limitation, but annoying and inconvenient. Biggest limitation, if you can think of the draft as a face that has a fillet on one side of the edge of it that runs perpendicular with the direction on the pole. To get around this, you usually have to tinker with the feature order with the draft expert to play for the draft where it should be. On the imported parts, you must have to use the feature work to remove the fillet and delete face to reintroduce the sharp corner. You may sometimes find when the draft doesn't work, and if the draft all faces that are tangent, then one of the situation where the fillets on the edge of that is roughly parallel to the direction of the pole. What to do when the draft fails. Part of the key success of the draft feature is you have the expectation line with the actual capability of the software recognizing the situation when the draft cannot work. You may not be able to correct the situation. Change the feature order combination draft features into single feature breaking the draft into the multiple feature chain with the geometry that are more than draft friendly. Sometimes allowable to reduce angle. The option can be used for parting line for a draft if you follow up draft analysis to make sure that you have sufficient draft in all areas of the model. This option enables the software to cheat somewhat in order to make the draft feature for the works of Solidworks help. The documentation actually has been more detailed explanation on when in this option will tend to just select the draft field, particularly in parting line, use to become partial, parallel, nearly parallel direction, and parallel pole. Draft can fail for a number of reasons. Intended tangent faces, some small sliver faces, complex adjacent faces cannot be extended with the face with the geometry area. When modeling is best, minimum the number of breaks between faces. This is especially true if the face will be drafted later. Generally, the face will apply with the draft with either flat face or the face with a single direction curve. You can expect Solidworks to draft anything you can throw at it, and it should try to give it good and clean geometry. When draft does fail for some reason that doesn't seem obvious for you, you should check the utility under the tools on menu. You also try to force a rebuild. Verification on rebuild turned on. Check utility checks of the model for geometry errors. Verification on rebuild check with more realistically feature for the intersecting the model incorrectly. Some features may fail with the option that would not fail when it happens there was something wrong with it. Feature is simplified default error checking didn't catch. Alright, Draft Expert is a tool used to create multiple neutral plane draft features quickly. You can also use the edit multiple draft faces without regard with the feature of the go to the face. Using indent feature view of the solid body as a tool that indents the thin wall, the area in the target is part with around the tool. For example, if you're building a plastic housing around with a small electrical motor, the indent feature shapes the housing creates the gap between the housing and the motor. Figure 13 show the property manager interface the independent feature as well with the geometry created with the incident. Alright, using indent teach feature. In this case, the smaller motor is placed where it needs to be, but there's a wall in the way. You would create an indentation wall. You would the same wall thickness, placing a gap of the 10th of an inch around the motor till the motor is brought into the wall part using the insert part command. The multi-body technique. Multi-bodies are examined in detail in Chapter 31, modeling multi-bodies. Workflow for indent its files open, create thin walled part, plastic sheet metal machine or so on, which would create an indentation. Create a new body that will be positive shape with a negative indentation. You can use the insert part, the insert of the external pre-existing part if you want. So for the indent command, choose the insert feature for the indent, select the thin wall part into which you want to put the indentation's targeted body, clean the area of the whole body, change the shape, remove the option is necessary. Use keep when selecting a location tool body where you want to create the thin wall of the area you've removed if you want to select the area to be free of material. Set the thickness of the material, thickness clearance of the free space between the tool body and the new walled material. The indent feature of the particularly effective if you have the part with it nearly finished with lots of detail with the might loss with the rolling back most making drastic changes to the feature's history has also worked in assemblies whereas the part can be the tool and indent with the feature of the modified with the related part. Cut option with a good for nothing feature with where you want offset with the cut with the body. It's just like a combined subtract tool, but with the ability to add an offset. Incidentally, the indent feature is one of those tools which I consider that really saved me a lot of time, and I have the customer asked me a major redesign on plastic assembly that would have meant redoing all the work I had done up to that point, and instead I was able to create a tool body used to indent the master model with a constant wall thickness and proceeded like nothing had happened. So it saved me 10 hours of particular project, keeping an open mind about unfamiliar tools. You may get an idea someday and save yourself a lot of time. Alright, working with shell. Shell feature powerful, yet sometimes tricky. The feature of the work with the Solidworks range of the except the word, regardless of the condition of the geometry required that the sum of the simple condition to be met with the general allow with the shell feature of the work. You must have the model where the minimum outside curvature convex is greater than the shell thickness. Shell works in 3D much like offset. Sketch works in 2D. Curvature of the too small that you cannot offset with an arc to inside. Small, same amplifies the shell. The thinner the shell, the more likely it is to work. Also, generally speaking, the body of your shelling doesn't have any face that are tangent and one another that you have with fewer problems, although the face that are not tangent are very pointy and sometimes cause problems. You can use the shell to hollow out the side. Hollow out the solid such as a bottle as shown in figure 3814. You can also use the shell feature shell to the outside, which adds material to the outside and remove the original solid. Shell feature can create multiple thicknesses, parameters, direction, shell, outward, show preview, multi-thicknesses, thicknesses settings. Using the multi-thicknessing shell, the figure 3814 shows the property manager set of the multi-thickness shell, and in this case the bottom of the bottle of the 0.150 inch thick, while result of the bottle is 550,000 inch thick. The top of the bottom is selected with the option. If you do not select the face for the option open, the bottle will simply be hollow with no openings. The image of the right with the figure 3814 shows half of the bottle in wireframe display to help you visualize the thickness of the difference. To better view the small you can find with the download material file, chapter 38 crease, bottle solid part. An important part of the multi-thickness setting of remember the Solidworks can assign the different thickness for the face with the connection by tangent. All adjacent tangent faces must have the same thickness. Another way to say that the adjacent faces that have different thicknesses must be not tangent to one another. The reason for this Solidworks we cannot transition between two thicknesses with two faces are tangent. Using shell outward. Shell outward is another option. It's especially useful for the bottles you may be more interested in modeling and contents per container of the actual container to help you visualize the idea thickening of the modeling of the liter of a frozen modeling of that liter of frozen water. Not the bottle, just the water frozen in the shape inside the bottle. Note that you have the contents you've created in the bottle. This is what the shell outward option is meant to do. Figure 3815 show the result where the inside original model shape of the bottle is shown and the outside was grown by the shell and outward option. Figure 3816 shows one of the tricky use of the shell feature of the figure. Show the planetary tray manufactured thermoforming. May be difficult to tell with the modeling on the part with the link to this because it could be shelled from either side of the top of the bottom. Alright, in this part, shuffle the faces will remove the shell feature, which you may think of doing with eventual examples of the shell function, but it works very well with the cases like especially thermoform type parts. Open the file called Chapter 38 Potting Tray Solid Part following download material with the final feature of the U that allow the better visualize the effective shell. Understanding shell workflow. Workflow, the use of the shell feature to produce the potting tray with the parts goes like this. Creating a solid part, one side of the solid represents the face of the finished model. The other side of it may be a simple black 3817 show of the model before applying the shell feature. Initiate the shell command phase to remove the selection box. Select all the faces of the shell to remove the will become the thickness of the face. This should amount to 6 faces of the block sitting up at the top of the tray. Use the shell preview option to have it difficult visualizing the result. Be aware that the option may slow down the operation of the software will sit while the shell property manager is open, but it will help you to see the result based on your current selection. Shell command has superior troubleshooting functionality when compared to the offset surfaces for more thickening of the Javelin Intech blog 2012-05 offset thickening commands. Using vent features. Vent features highly specialized and intended both sheet metal and plastic parts. Figure 38 and 18 show examples of vents. The part used in 3818 can be found with a download materials file called Chapter 38 Vent Solid Part Vent Feature. 4 main components: boundary, ribs, spars, and fill-in boundaries. Figure 38.9 of the property manager vent feature of the representative of the single column property manager by here splits into 2 columns that fit the format of this book. The vent feature also has several rules, but much of which are explained with the help feature of the interface. All sketch elements must be able to the same sketch. The entire feature must exist on a single face. No sketch element can hang off the face. Fill-in boundary may not have the nested contour. We must have one rib before you can create any spars. Spars and ribs can be interchangeable as long as at least one sketch element in the rib selection across to the boundary. Rib and spar have selected sketch elements that aren't tangible lines that meet an angle. Intersections will have notches on the end of each of the sketch line were extruded individually. See the circular triangular example, figure 3818, as well as workaround. You can option to remove the notches. Use the delete face feature of the delete patch option. Selecting the 2 flat face of the notch to be deleted. Boundary is outlined in the cutout. Figure 3820. Boundary is elements of the rectangle, the ribs, the concentric circle with the spares or radial lines. Workflow vent. There's also a file with the check with the create the sketch of the boundary ribs and spare with the filled boundary rib. Spare sketch elements represent the midline of the feature. Select each element of the boundary rib, spare, and fill in boundary in the respective selection box. Select the width and thickness of each item. Optional trim the radius of the fills. Option geometry property panel. Fill is the edge sharp corner of the feature. If the fill fails, the point identify which of the corner failed, the whole feature will fail. Use the flow area panel to calculate the open space for the vent. Use the favorite panel with the vent property manager to store the commonly used setting. Favorites can be saved externally, shared with others. Alright, using plastic evaluation tools. Plastic evaluation tools Solidworks enable you to automatically check for the model for the manufacturer issue for the draft of the undercut thickness, for the curvature of the tools. You have to do this drafting analysis for the undercut checker and curvature tools. Using the draft analysis for the Solidworks draft analysis tool is the most when you're working with the plastic part of the part, which shown in figure 3821 has many situations where they're going to encounter analysis. Plastic part of the draft analysis tool has 4 major modes: basic, gradual, transmission phase, classification, fine, steep phases. Draft analysis parameters: angle, adjusting triad, phase classification, color setting, gradual transition, positive required draft, negative draft. Draft analysis found that the view of the display is being the like a section view of the tool is either the on or off the benefit because of the update of the face of the colors dynamically as you model. It also has some drawbacks. Display method of the tool leaves the colors looking very flat without highlights over the other curved face, which makes parts, especially curved parts, very difficult to visual. Basic draft analysis with no options. Select the symbol of color face for the red, green, and yellow colors might be the display transition of the draft, shifting between two classification transition. Type shown figure 3821, image of the right with a clear view of the method. Look at chapter 38 draft analysis, solid part of the download materials. You can perform all the type of the draft analysis. Solidworks by selecting reference flat face of a plane, setting a minimum allowable angle. Figure 3821 allowable will have at least a 1 degree draft except for the rounded edge shown. The image of the right and the dome. Both of the edge shape of the transition from the edge less than 1 degree to the angle the greater than 1 degree. Basic analysis for the good visualization chain of the draft angle, but it also has some less desirable properties which become apparent as you study the other types of drafts. Gradual transition. Although the basic draft analysis can show the transition draft with gradual transition draft analyzes takes a step further with a gradual transition draft. You can specify the colors. It is also useful because we can distinguish draft with a different amount of the color. May be difficult to tell in grayscale image in figure 3822, but in ribs, both the ribs which were created in 1 degree have a slightly different color than the floor of the part. The walls have a different color, but the nose of the cavity core directions have different colors as well. Called positive and negative draft and draft analysis. You may want to open the parts of the Solidworks, recreate the settings, run the analysis so you can see the actual colors. Some problem arises when you use the display mode, the first being the flat with a non-open GL face shaped and shading with the achieve the transition color. This often makes it difficult to distinguish curved face with the face of the face with different directions. Second problem is that you cannot tell the boss on top of the dome that has absolutely no draft. In fact, there is no way to distinguish between the face that leans slightly toward the cavity and face that slightly toward the core. Third problem is strange effect of the appear of the filleted corner of the corners were filleted after applied to the draft and before the shell, so the filleted corners should have exactly the same degree of the side. However, from the color plot, it looks to be a few degrees more. Caution: gradual transition gives an interesting effect, but isn't a reliable tool for determining on its own whether a part can be manufactured. Face classification draft analysis groups the face with classification using the solid non-transition colors. You notice the big difference between the coloration flags. Classification draft the analyst face with the basic gradual transition face. The face with classification using the open GL face shading, which is the same as that of using Solidworks by default. This allows better shading different between the base faces of the different direction. The basic analysis of colorization looks like all the faces are painted on the same flat hue regardless of which direction they are facing, which makes shapes more difficult to identify with the non-open GL alternative shading method. Makes it possible to display transition color. Solidworks open GL shading cannot do this. Another advantage of using OpenGL shading is that the face color can remain on the part after you've closed the draft analysis property manager. Face classification draft analysis also had a classification that isn't used by basic draft analysis. For the term straddle faces refers to the face and straddle parting line on the face that do their curvature pulled from the both directions of the mold. These faces are needed to be split on these part of the straddle faces shown in figure 3823. Show the straddle faces. Light bulb icons left with the color swatch that enables you to hide face for the classification. Use the will try isolate certain faces, visualizing groups of faces in a certain way. This could be an extremely useful feature, especially when you use this very complex part with large number of faces, some which may be small, easily lost in the mix with the other large faces. Face counts of the period of the color swatch is a very helpful feature for they are absent of the basic draft analysis. Consider the use of the draft express for a situation where you've had to add a draft to model with the use of the built-in draft analysis. Best practice: I prefer face classification draft analysis because it is clear that I need additional detail regarding the other type of the face. I might run a steep face draft analysis supplement with the best pair. Isn't that the file with the favorite type of the draft analysis, but you would understand what you need to know. Then use the appropriate tool to find this information. They include the running multiple analysis to collect all necessary information. Finding steep face. The steep face is defined as a face with a transition for left than minimum angle to more than a minimum angle. The steep face is different than straddle face. The straddle faces are actually positive and negative, while steep faces are entirely positive and entirely negative. On this part of the dome, inside of the part is classified as a steep face, shown like 3824. And that's in draft analysis. Understanding draft analysis workflow. Workflow of the draft analysis tools files open part of the which one analyze the draft, select the view, the display of the draft analysis, select the value of the tab of the command manager. Select the plane with the planar face with the direction pull within set of the options you want. You the visual of the draft with your part of draft colors displayed immediately after you select the direction pull. If you want to keep the colors in them while you're working, click on the green check mark icon, draft icon, analysis icon toolbar menu will display selected. If you do not want to set the colors anymore, click the red icon. If you want to click the green check mark icon, then later want to turn off the draft analysis display of the colors, you must deselect the draft and analysis icon and the toolbar on the menu. Alright, using thickness analysis to run thickness analysis about analysis of the two modes showing thin regions, showing thick regions. Of these show the thick region. Thick regions are most versatile. Using the show thin regions option, show thin region option thickness analysis requires the input minimum acceptable thickness. Every thickness above the value is turned to neutral gray, and every face of the thickness below the value is displayed on the graduated scale. Figure 38.25 show the property manager for the analyst for the result of the same part you for the draft work for this preceding section. One of the things to watch out here is some of the anomalies occur when applied with these analysts fill the faces. Faces show the color were created with the shell feature and should be exactly 1/10 of an inch thick. However, it does not correctly represent the undercut end of the part of the thickness of the ribs. A nice addition to this tool would be identification of the minimum thickness faces. Perhaps you could submit an enhancement request using show thickness regions option. The show thickness region option works with very little different show within regions. You need to specify upper thickness limited value with beyond everything is identified that is too thick. The effect example, the nominal wall thickness of the part is shown at 1/10 of an inch, and thickness of the region limited is set at 1/1200th of an inch. For this type of analysis, the color gradient representation thickness of 1/100th of an inch and 12/100th of an inch, while the analysis of the color gradient represents the value of between 1/1000th of an inch and 0 inches. The analysis can produce the use of anomalies result especially for the corners, also the middle angle, and again, the useful tool of the non completely accurate. Use it to find problem areas that may have been considered, but you also certainly examine the result critically. This feature can regenerate a report which, to some extent, they answer questions about how and why the classified faces of what to do it does. To get a complete picture of the situation may be useful. Result for the thinness analyst option. Analyzing parameters shown within thin, thick regions. Save report color settings, full color, keep thickness, targeting, thickness colors, the continuous discrete thickness scale, performance of accuracy, face for the local analysis resolution. Okay, lack of the report. You've been resolved with making a design manufacturer decision. Sample the report shown in 38.26. Understanding thickness analysis workflow of the thickness analysis tool is followed on thin wall part of the sum of the variation thickness. Start with the thickness analysis tool with the selecting tool thickness analysis. Click with the icon value with the tab of the command manager. Select the thin and thick region depending on what you are most concerned about. Sample thickness analysis reports in detail for the region analysis. Each enter lowest acceptable thickness thickening region analysis for the enter lowest high acceptable thickness values. Options like the individual set face the local analysis performance accuracy panel. This will allow you the option to get more accurate display. The default is the least accurate option. Accuracy comes at a low cost of longer analysis time. Click on the calculate. Calculate the may take it a few seconds longer depending on the complexity of the part. For instantaneous display, if the color gradient on face of the blue indicates the wall is too thin, and red indicates that it's too thick. Undercut analysis tool is the view display menu with the evaluate tab of the command manager. Is also have the offer on and off display tool, which changes dynamically as you change the model. Undercut the analysis conceptual flow will give the incorrect result every time. However, you think of the table as being changed slightly, but the result will become partially unusable. Even if you and your mold builder knowing that the part of the absolutely no undercut, the undercut analysis tool nonetheless always identifies all the faces to be undercut. In fact, the only face for that tool identified that are not undercut are faces that have no draft on them, even if they in fact undercut. The only time they correctly identify the undercut is when it classifies the undercut as a undercut. Faces that have no draft or uncooled undercut are improperly identified as a simple no undercut. You may want to avoid this tool because of too much interpretation and correct result if necessary. However, you still want to use the here translation guides may help you. Direction 1 undercut should read the pull from direction 2. Direction 2 undercut should pull read direction 1. Straddle undercut should read straddle faces. No undercut should no draft primary draft direction may be occluded under faces. Occluded undercut should read occluded underfaces that have draft and completely irrelevant primary draft direction. So that doesn't include occluded undercut faces that have no draft in primary direction. Figure 38.27 shows the property management of the function of the result. If you want to test the part of the download material of the file name, chapter 38, draft analysis, solid part. Undercut analysis, parameters, coordinated input face and adjustment tray with highlight or occluded region. Undercut face direction 1, undercut direction 2, undercut included undercut, straddle undercut, no undercut. Understanding the undercut analysis workflow of the undercut analysis tool. Open a plastic part model of which you find the undercuts. Open undercut analysis of the tool view. Display with the using icon. Evaluate the tab of the command manager. Select an axis flat face of the plane. Do a step with the direction pull of the model. Interpret the result with using suggested labels listed earlier. If you want to keep the color display, click with the green checkmark icon. If you want model display with the number of the model, the color, click with the red icon. If you choose the green checkmark icon but want to turn off the color display, turn on the undercut detection tool by clicking on it again the toolbar in the menu bottom line. Solidworks provides a vast amount of plastic functionality. The more you use the feature, the more powerful you'll find them. The back home in the section nature of the use while the power, flexibility are amazing. You will find the incredible range of parts you can make the evaluate the features of automated functions. They answer to all the problems. However, you need to be well versed in the world. Workaround takes me for more collective situations. Master it. Follow these steps. Great machine matching mounting bosses. Create a new part. Extrude the solid box from the mid plane option with the side of the box at least 4x4x4. Use the shell feature to hollow the box out with a wall thickness of 1/10 of an inch without selecting the use to remove. Use the interface feature to select the solid body original sketch plane to create the two separate bodies. Make sure that you turn all the feature result option. You want to keep the outer two shells bodies so that they are to the left. So that you are left with the two halves on the open box. Sketch a circle and circle of the face of the block parallel to the split plane in shown. Initiate mounting boss. Using a circle to locate the boss, the edge perpendicular to the split with the mid direction. Select hardware boss type head option. Other options shown in the following graphic. You cannot go back to chain with the boss from hardware boss to pin boss later. Using setting preceding graphics with it for the fins, make sure for the model edge of the fixture direction of the fins, except for the mounting boss option. Play with the section view with the C with the inside of the box, still C with the mounting boss. Starting with the mounting boss feature again, select the object, face the opposite of the original mounting boss. Face to put the new boss, select the circular edge of the first boss. If the locate with the new boss, select with the hard boss, threaded type of the shown figure following graphic. Use the flat mating space and specify the length. Determine the direction of the fin, second boss, and acceptable second boss feature, save the part. Master it. Open the part you created with the previous master it exercise. Prepare to add a lip to groove the features. Save this function and rename the master it lip groove solid part. Use the tooltip lip groove with the property manager shown here with each of the selection. Make proper selection of the lip and add material groove with the remove the material. Visualization made it difficult when the feature of the multi-body part. Solidworks temporarily hides the appropriate body with the appropriate time and allow it to make the selections. Master it undercut analysis tool had been incorrect, and since it was added to software, a little embarrassing. Consider the fact that the rest of the software is generally pretty good. It's likely developed in someone that didn't understand the concept at all. Your mission should choose to accept it if you write an enhancement request with the SolidWorks to give them a fix to this tool using either my suggestions earlier in this chapter or your own suggestions. Chapter 39, using mold tools. And that should be the last chapter.